The percent of female wage and salary workers who are paid hourly rates is given below for the years 1979 to 1992. Number 1, find the least squares line. Okay, we'll be asking GeoGebra to do this for us. So if we fire up GeoGebra, you'll see I've already put the data in. So to get the regression line, we highlight the data, click and drag a box around all the data, both columns. First column should have the independent variable, and the second column should have the dependent variable. And then from the menu up top here, we click the triangle to get two variable regression analysis and analyze. What comes up is a scatter plot. So to get the linear regression model, we choose from the regression model drop down linear, and it shows it. So this red line is the linear regression model, and here's the equation. So y hat equals 0.1656x minus 266.8863. Okay, so let's write that down. It's y hat equals 0.1656x minus 266.8863. Find the correlation coefficient. Okay, back to GeoGebra for that. We have to now click the Show Statistics button, and we see it pops up right here. The correlation coefficient is 0.9448. So R equals 0.9448. And now number 3, does it appear that the variables are linearly related? Certainly from the scatter plot, it looks like all the points are very close to the line, and we have a correlation coefficient that is almost 1. It's 0.95. So we don't expect that we do suspect that this correlation coefficient is significant. However, we should still run the test. So we're going to run that significance test. Then number 3, we're going to run the significance test and find out to make sure. So we calculate the test statistic, which is R times the square root of n minus 1. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data, 11 observations. So 11 minus 2 is 9. And then we divide by the square root of 1 minus 0.9448 squared. Okay, and if we punch that in on a calculator, we should get something like 8.648. Okay, now we calculate the area of the tails, putting on T9. We put the T statistic way over here, so this is about 8.648. And we're interested in, again, we make this symmetric, and we're interested in the two tails. So it's twice the area of this tail, so we're going to go twice, and the area of that tail is 1 minus T distribution. 8.648. Okay, and again, we need GeoGebra to actually calculate that. Whoops, needle in the parenthesis, and we go to GeoGebra. So we're done with that. Go to the computer algebra system, and we'll ask for 2 times 1 minus T distribution, 9 degrees of freedom, and a variable 8.648. And there we go, 0.00001. So very small. So the p-value this is the p-value, is 0.00001, and that's much less than the default level of significance of 0.05, so that means it is significant. Okay, so it does appear that they're linear related, so we can answer yes for two reasons. The scatter plot, looks roughly linear. And the correlation is significant. So that's it. That's how we check. Correlation is significant. Okay, number 4. Use the model to predict the percent of female wage and salary workers in 1988. Should this value be trusted? Let's test. Let's go. We have to get the model back. So we want 1988. 1988. And it's 62.42. So y hat 1988 62.42. Okay, so if we go back to the chart, 1988 would be right here. So it's within the range of the data we're given for the dependent variable. So, and we've determined that this is a good model, so there's no reason we should not trust this value. So yes. So yes, it's trustworthy. And that's why, because it's within the range of the values of the independent variables.